Alright, so absent kids, I forgot about you. So we need to go back. I'm going to just go scroll back a couple pages, run through this very quickly.
You forgot about Nick.
Nick is my absent kid, and Dom. Okay, the bell ringer, what we did is we found a common denominator for 15 and 25. That was 75. If we're going from 15 to 75, we had to multiply by what? 5. So this makes it 5 times 2. That's how we got our 10. Same thing here. 25 times 3. 3 times 3 is 9, giving us 19 over 75. Next page. Okay, in order to add and subtract rational expressions, we need a common denominator. It records the screen as well, yes. Alright, an object is 15 centimeters from a camera lens. The object in focus on the film. When the lens is 10 centimeters from the film, find the focal length of the lens in centimeters. So what we did is we plugged in for D1, D2, 15 and 10. We found a common denominator of 30. We added them up to get 5 over 30, reduced to 1/6. The focal is 6 centimeters because it's simply the denominator, this F right here. Okay, so you probably want to pause this so you can type it all in and then start back up when you're ready. All right, for those of you that are actually here, go to the next page. All right, suppose an object is 20 centimeters from the camera lens. When the object is properly focused, the lens is 5 centimeters from the film. Find the focal length of the lens. So we're using the same formula, that 1 over F equals 1 over D1 plus 1 over D2. Okay? So what you're going to do is you're going to set up your formula. D1 is going to be what this time?
How did you get the subscript or the postscript?
I'm not sure. I haven't figured that out yet, Jesse. For now, just yeah, that works. So D1 is going to be
20.
and D2 is going to be
5.
So what I want you to do is go ahead and plug those numbers in and solve it out for me, and then we'll go over it in just a second. Okay, so we have 1 over 20 plus 1 over 5. Common denominator? 20. So this stays 1 over 20. 1/5 becomes what? 4 over 20. Good. When we add them together, we get 5 over 20, and this reduces to 1/4. So what is the focus? 4 centimeters. Very good. Any problems? That was a piece of cake, right? Okay, so let's get a little bit harder. Finding least common multiples. Okay. Finding the least common multiple of 4x squared minus 36 and 4x squared plus 36 plus 54. What do you think we have to do? We have to factor. Who said that? You said it? Very good. We have to factor. Okay. So our step 1. So right down here, we're going to write in the step. Right? Factor. Factor completely.
C-O-M-P-L-E-T. E-L-Y.
E-L-Y?
Yeah.
Really? I wouldn't have gone with the E.
Yeah. That would have been completely.
Oh.
I think I wanted to find the answer.
Really?
Yeah, that's right.
If it ends in an E for the root word, then just E-L-Y.
It looks like completely.
Why don't you look it up on the internet?
You don't need to look it up. It's right. I'm telling you. 100%.
It looks weird without the second
silent because it makes the first
Yeah, I guess it does look weird. Okay. Conversation about how to spell completely. All right, so factor completely. So let's look at 4x squared minus 36. We learned how to factor, and we did a ton of practice factoring yesterday, right? So what's our first step when we factor? Step number 1. Huh?
Add the 2 sides of the
Not yet. That's before that. First step when we factor, always. What are we looking for?
Find the problem.
GCF?
GCF first. Does 4x squared minus 36 have a GCF?
Yeah.
What is it? 4. You could pull a 4 out of 4, you could pull a 4 out of 36. So put a 4 in a set of parentheses. What's going to go in that set of parentheses if we factor out a 4?
X squared minus 36.
X squared minus, be careful. Remember, we're factoring it out of 4x squared and we're factoring out of 36.
Can't put squared in.
Yeah,
9.
Put the squared first and put the x in the back.
Yes, put the x squared in first, the squared, and then put the x in the box. I'm doing this. Okay, so we have 4 times x squared minus 9. X squared minus 9. Look familiar? Say it again. X plus 3, x minus 3. Good, so you're going to have your 4, x plus 3, x minus 3. So that is factored completely. So let's hit enter and go down to the next line. Now we want to factor 6x squared plus 36x plus 54. We can take a 6 out of it. Good, so 6 is our GCF. What's going to go in the parentheses? We factor out a 6.
X squared.
Uh-huh. Keep going. Plus 6x. Good, keep going. Plus what? Okay. Am I done? Can I factor again? Okay, so I've got 6. Parentheses. What's going in my parentheses? X plus 3. And what goes in my next set of parentheses? X plus 3 again. Good. Alright, so I have 6 times x plus 3 times x plus 3. Good. So now, what I'm going to look for, and this is step 2, so when you scroll down on your paper, see if I can do that. Notice it says down here step 2. You ready? Okay, write each factor the greatest number of times it appears. And then simplify. Okay, so you're going to write each factor the greatest number of times it appears, and then you're going to simplify. So we're looking at this piece here and this piece here. It's the heater. Okay, so write each factor the greatest number of times it appears and then simplify. So what we're looking at is these two pieces here. We want 1 or as many as we need. So look, we have a 4, an x plus 3, an x minus 3, a 6, and 2 more x plus 3s, right? So we have to write 1 of each. Okay? We have a 4, so we have to write that down. We have 6. I think I wrote something wrong. We have an x plus 3. Yep. We have 2x plus 3's in this one. So we need to write it down twice. Okay? So as many times as it shows up in each. It shows up twice in here, once in here. We only need to write it twice because it'll cover for this one. Okay? And then an x minus 3.
Why do we only get already twice?
Because it has 2 in here. This only has 1. We'll be able to add another x plus 3 to this one if we need to. Okay? See this 4 here? How can I break up 4? Factors. 6, how can I break it up? I'm going to ask you to go back and erase something. I'm going to add something different in there. Sorry. Okay, so look at our factors now. We've got 2 and 2 and 3 and 2 instead of 6 and 4. Okay? How many 2's am I going to need? And then what else? 3. Sorry about that. My mistake. I missed a step. All right, so I've got 2 times 2 times 3 times x plus 3 times x plus 3 times x minus 3. There's got to be an easier way to write that, right? Yeah. 2 times 2 times 3? So we've got 12. Can I rewrite x plus 3 so I don't have to write it twice?
X plus 2 squared.
Yeah, x plus 3 squared and x minus 3. Okay. So when we're finding these common multiples, we have to factor it out to its prime factorization and then take as many as we need to make it work. Okay, we're going to do lots of examples with this. This is the trickiest part of adding and subtracting rational expressions. Okay, example 4, find the least common multiple of each pair of expressions. So what I want you to do is factor both of these expressions out and then find the least common multiple. Just do what we just did, okay? You're going to do A and B. You can work together with your partner and we'll come together and go over it in just a second. All right, so I was kind enough to do this one on the board for you, and we got 6 times x plus 2 times x plus 5 times x minus 5. Those of you that are home watching this, figure it out. And come talk to me.
Hi there.
Hi, Nick. Okay, so 5x squared plus 15x plus 10. Do you see up there? 5. So what you're going to have is 5x squared plus 3x plus 2, correct? Are we done?
No.
Need to factor again. 5x plus 1, x plus 2. Did we all get that correct?
Yeah.
Okay, so now we need to look at the second one. What's the GCF for 2x squared minus 8? When we pull this out, it becomes x squared minus 4. Are we done? Difference of 2 perfect squares. What does this become? X plus 2x minus 2. Perfect. Okay, so now we have to take a little bit from each one here. We know we're going to have a 5 and a 2, correct? So why don't we combine those now? What does that give us? 10. All right, we've got an x plus 1. What else do we have? Done. An x plus 2. Now I only need one of them because there's one in each. What else do I need? An x minus 2. Okay, so that is our common multiple. Okay, how'd we do? Adding rational expressions. We have 2 rational expressions we need to find the sum of. Okay, sum means that we are adding. So in order to find the common denominator that we're going to use, we're going to have to factor out our denominators. Okay, to its prime factorization. So what you're going to do is go to the end here, add an equal sign, and then add in 2 fractions on plates with an addition sign in between, and we're going to factor out our denominators here. Okay?
Factoring's just the best.
Oops, that's not what I needed.
Man, I don't know what I'd do today if I didn't factor.
You know you'd be so upset.
I'd probably be
If
sleeping.
you're, when you're canceling out, like, do you have, like, x to the square, can you cancel out just the 4? Or, like,
No.
things like that, you have to cancel out the whole thing.
Yes. Okay, so x squared plus 5x plus 4, what does that factor to? X plus 4, x plus 1, good.
Wait.
because it multiplies to be
Yeah. All
a
right.
positive 4 and adds up to be a positive 5. Very good. Okay, next fraction. And then we're still going to have 1 in the numerator. Our denominator, when we factor, we're going to get 3 times x plus 1. Good, that's one of our GCFs. All right.
My whole thing didn't come down.
What about that 5x?
The top is 5x.
It is? Did I? Oh,
Mm.
I should be fired immediately.
You're fired.
I'm sorry. Okay, good. So we've got that, right? So what is our common denominator?
X plus 1.
X plus 1. Need more.
That's it.
Have the x plus 1, x plus 4, and 3.
Good. So I've got 3. Oops, that's in the wrong spot. 3. X plus 1. And x plus 4. You have to use one of each, okay?
And we don't need that other one because it's in both of them.
Correct.
Oh. Wouldn't
Okay.
the top one just be 5x or 6x?
So we've got x plus 1, x plus 4. They're common here and here, right? What did I have to add on to that? Just the 3. So in order to get the 3 over here, I have to multiply it by 3. So what do I have to do to the top? Multiply by 3. So my numerator, that's not my numerator, is 3. Okay? So you have to multiply whatever you needed to add to the
What
bottom.
about 5x though?
We haven't gotten over there yet. Plus, we have to add this. We're changing both denominators here. Our denominator is 3 times x plus 1, x plus 4. Okay, so our original denominator was 3 times x plus 1. Now it's 3 times x plus 1 times x plus 4, right? So what do we have to multiply to it? The x plus 4. So in the numerator, you're going to have your 5x. And then in parentheses, you're going to add, multiply to that, and x plus 4.
How do we get that x plus 4 there?
Because, see our original denominator here? 3 times x minus 1? What's the only thing that this one includes that this one doesn't?
Oh, right.
The x plus 4, right? So you have to multiply that by x plus 4 stuff. Okay, good. So now let's go a step further. Put in your equal sign. Let's combine this to make one big fraction. We're going to go down to the next line because I'm losing stuff. Oh, I hate when I do that. Did I make it disappear?
Maybe just
Come on. Work with me.
Maybe you can copy and paste that.
I bet I can. You are so smart. What would I do without you? Control. How do I cut something? Control
C.
Let's
Okay.
copy. X. Control X.
You have the copy, you can quick cut it.
There you go. Control X.
Sorry, make the tab, is it?
Control.
Wait, not down
Not
there.
down.
Yeah, there's a curve down there. Press the enter button. Tab. The one below the enter one. Oh, there you go.
Control what space?
B.
Control B. All right, so now we've got our common denominator. Now we need to add our numerators together. So I've got 3 plus. Can I factor that out? Distribute it out?
5x squared.
5x squared. Okay. 5x squared plus 20x. Right, that's our numerator. Go down and we're going to keep our same denominator. Okay. I've got 5x squared plus 20x plus 3, right? Yeah, chances are it's going to be able to be factored. We know we're going to have 5x and an x. 5x plus x plus. We just need to figure out what goes as those two bottom pieces. It has to multiply by to be 3, so we know our factors are going to be
1 and 3.
1 and 3. So let's try a 3 here.
It's supposed to be 5x plus and then just turn.
Well, you have to put something in there.
How did we get it?
How do we get 1 and 3?
Yeah, how are we supposed to get 20x out of 3?
Okay, watch. We've got 5x squared plus 20x plus 3, right? We know that it has to multiply to be 3 at the end. Does 1 and 3 multiply to be 3? To get the center terms, we actually have to FOIL this out because we have a leading coefficient greater than 1. So we have 5x squared plus 15x plus 1x. 15x and 1x gives us what?
15x.
So is that going to work? No. All right, so we need to try something different. Let's try 1 and 3 this way. Okay, so we get 5x squared plus 5x plus 3x. That also doesn't work, huh? What am I missing? Okay, so can we get it to factor in any way? Can we get the top to factor at any with anything? No. So if it doesn't factor, that's your answer. Okay? That's your answer. All right. How are we doing? We're finding the common denominators, okay?
A million pages left.
Aw, next page. Okay, simplify. So go ahead and find the common denominator. And then simplify it out, please. Okay, Samino, you like to talk? X squared minus 4x minus 12. How do I factor it?
It would be x minus, or 1 over x, no, x
Yeah.
minus 6, and then x plus 2.
Good. Did everybody get that factor correctly? Okay, Janae. Janae?
Yeah.
Janae. 4x minus 8, or 4x plus 8.
It would be 4 times x plus 2.
Good. Did everybody get that part? Factoring should start getting simpler for you guys. You've had quite a bit of practice now. Okay, GCF, or I'm sorry, did I just say GCF? I mean to. Common denominator. What do we need to include? 4, x plus 2, x minus 6. Good. Okay, so here's my original right here. We've got x minus 6, x plus 2. Here's what I have now. What's the only thing that we had to multiply? 4. So what's that numerator become? 4.
Okay, how did you get that?
How did I get what?
The denominators.
How did I get this?
Yeah.
I have 1 of each. X minus 6, x plus 2, and a 4. I didn't take x plus 2 from both because we have 1 in each.
How did you get 2x minus 6?
What? I don't have 2x minus 6 anywhere in here.
So how do you get 2x minus 6 if you got x minus 6 2 times?
There. I have x minus 6
Yeah.
once.
And another one on the right.
These are two different fractions with the same denominator.
Okay, I got you. Alright, I got you.
Okay, so here's my original. 4 times x plus 2. What did I have to multiply to it? X minus 6. So this becomes 3 times x minus 6. Do we get that far?
It's not 3x. Oh, yeah, it's 3x.
Okay. So we're going to go a step further now. We're going to combine it all. We have 3x squared minus 18x plus 4. Is everybody okay with how I wrote that?
Yeah.
Okay. And the denominator, I have 4 times x plus 2, x minus 6. Yep. And that's where we're going to stop right there, because the numerator's not going to factor.
I got it right.
Okay. How'd we do? Did we get it?
Yeah.
Good. All right, so now I want to switch gears a little bit and talk about subtraction. So we're going to skip over. We're going to go to page 1.10.
Wait, can you go back to the other one real quick?
I already got rid of it. It was ink, so look at your neighbor. we do the same exact thing for subtraction when we talk about common denominators. Our only issue is going to be when we start looking at the numerators and we start talking about subtracting polynomials. Who remembers what happens when we have to subtract polynomials?
I don't know.
Yeah, keep, change, change. That's the keep, change, change piece. Good morning. How you feeling? I'm glad you could make it to my class. We missed you.
Skip the napkins.
Oh, good boy. Okay, so
Alright.
first thing we're going to do is we're going to talk about our common denominator. So our first step is to do what? Factor. Okay, so let's start factoring. We have 5y squared minus 125. What's the first thing I'm pulling out? 5. Got a GCF here. So this becomes y squared minus 25. Y squared minus 25.
Yeah.
Seen that before, right?
No.
Yes, you have.
How have I seen that?
How do you know what I've seen?
I know what you've seen. Y minus 5,
That's a
y
lot
plus
creepy.
5.
I'm not gonna lie.
So y minus
I
5,
haven't
y
seen
plus
that.
5 is how that factors out.
How have I seen that? I don't get it.
You gotta go
Difference of
back.
two perfect squares? Because I've shown you a difference of two perfect squares a million times now.
A million?
Oh,
Yes.
that's what you meant. I thought you meant like that was some special thing we have to know that.
It is a
y
special
squared
thing
minus
that you have
25.
to know.
I thought you meant that specific one though.
It is a specific one that you have to know.
The-
All right, so let's look at the other denominator. GCF?
Ooh.
You actually fix that later.
Don't play. Talking to the computer. So we get 3 times y plus 5.
Transfer to Brooklyn or something?
Huh? You're confusing me.
Excuse me?
I don't talk ghetto.
You just said don't play. That's pretty ghetto.
No, I don't think you guys get it.
I need
I don't think you
batteries.
got it in that.
Yeah, I don't know.
Okay, so we've got 5 times y minus 5 times y plus 5, 3 times y plus 5. Who can tell me my GCF? Or my, why do I keep saying that?
BTF?
My common denominator.
15 y plus 5 y minus
Perfect. 15y plus 5y minus 5.
Represent, we just keep speaking the same. Or no?
What?
You don't need that?
Yes, you do.
I'm just gonna.
15y plus 5y minus 5.
I have no idea what's going on.
Me neither.
It's the same thing with Bendel.
Why did you?
Yeah, I have not known what's going on.
Why did I erase it?
Did you say that?
So I can save room.
Did you have any notes from time on TeacherTube?
Good.
See my update?
No. Control C. Control. How do you how do you
Being
think?
that why.
Why do I keep thinking Y?
Who knows?
Okay, so we've got our common denominator, right?
Are the top still the same?
No. What did we have to multiply our first one by to get the denominator? 3. So 7y becomes what? 21y. Okay. And what do we have to multiply this one by? 5. So this becomes
The Bellman. The Bellman.
20. Wait, no.
The Bellman.
Say that again. What do we have to multiply it by? 5 and y minus 5, right? Yes.
Where did you get the number to make 7y 21y? Like, where'd you get the 3 to multiply it by 3?
Because this is 15. What was the one out here? It was 5, right?
Oh, okay.
Is there any way to invert a fraction?
Invert?
Yeah.
What do you mean? Flip on there?
I put the denominator on
To
top.
take the reciprocal? I don't know. You could,
You
you
just gotta
could
write
cut
it.
it and paste it.
Oh, fair.
Okay, so for this one, here's our original. 3 times y plus 5. What did I have to bring to it?
5 and a y minus
5 and a y minus 5. So we have to multiply 4 times 5 times y minus 5. which becomes what? 20y minus 5. 20 times y minus 5. Okay, so we got 20 times y minus 5. So now let's distribute that out. We'll make it one big fraction. 21 minus, now here's 21y minus, here's the tricky part. I have to distribute this piece out, right?
Yeah.
So this is going to be 20y minus 100. Okay, I've got to subtract this whole thing. What do I have to remember to do? Add the opposite. So we keep, change, change. So this becomes 21y minus 20y plus 100. Remember, you have to keep, change, change.
You can combine like this though.
Yes, you can. What could you combine it to?
It'd be y.
It would be y. Good. We're going to do that in just a second.
Wait, just why?
Y.
It'd be plus
21y minus 20y.
Yeah, but it'd be plus 100.
Where did I have? I lost it.
You didn't have a type
Thank
of-
you. There we go. That'd be it.
That's pretty good.
But it takes a little getting used to. You guys are starting
That was almost the same as addition, you just had to keep changing.
Yeah, it's the same exact thing as addition. The only thing you have to remember is when you subtract polynomials, you have to do that keep, change, change. Okay?
So the only thing we changed was the,
Complex fraction. You're going to type it. You ready? A fraction that has a fraction in its numerator or denominator or both.
was this the one we had on that one? On our homework?
Yes. It's a fraction. Has a fraction in its numerator. And if you want to shorthand numerator, that's fine. And denominator, or both. Fraction that has a fraction in its numerator or denominator or both. A fraction is simply what again? What's fraction? What's a fraction do?
Fraction singular.
Huh? Somebody said it. Divide. Fraction just means divide. Okay? And we did one of these on our homework where we did the keep, change, flip. Remember?
Yeah.
So now the only difference between the one we did on our homework and the ones we're going to be looking at now is we're going to be looking for common denominators before we do the keep, change, flip. Okay? So an example of a complex fraction. Ready? Fraction template. Another fraction template. Oh, that's not a fraction template. So I have two.
How'd you do it?
Fraction template, fraction template. 1 over x over y. That's a complex
Divide
fraction.
divided by x divided by y, or 1x divided by y.
Be 1 over x divided by y. Okay, so another example, I'll give you one more. Fraction template. 3 over 1 minus fraction template 1 over 2y. That's another complex fraction. These are the types of complex fractions we're going to be dealing with right now, the second one. Okay? Because, look at the denominator. Can I use it the way it is currently?
No.
No, I need to make that one fraction before I can finish it.
I don't like it.
Okay? Do we all have this?
uh,
Okay, so here's our first complex fraction. Are we ready? Okay, method 1 is to find the LCD. Yep. So step 1 is to find an LCD.
Like you're dedicated.
Did you get
Semicolon?
did you do that?
It has to put an
Um,
Why?
It's on there somewhere.
it's on the right.
What?
Okay.
It's harder to do our spine test questions too.
Okay, so here's our first one. We're looking at the first fraction, correct? First thing we need to do is look at the numerator by itself. We need to find a common denominator in the numerator. What's that going to be?
Wait,
Look at the numerator. 1 over x plus 3. Remember, this is the same thing as this, right? What's the common denominator? X. You all see how we got that?
No.
No, not at all.
Yeah, no.
Okay, we just did least common multiples, correct?
Yeah.
We have an x here and a 1 here. We have to include one of each, right? What's x times 1?
X. Such as 3
Just-
over X.
Just 3 over, well, what did you have to multiply 1 by to make it an x?
X.
So it becomes,
Okay.
alright, so let's try this. Put in a fraction template, put in another fraction template. Okay, 1 over x is going to stay the same, because we're not changing the denominator for that. Plus. Put in another fraction template. Okay, so we said we wanted to make this denominator x, correct? It was originally 1. What do we have to multiply 1 by to make it x? So what do we have to multiply 3 by? So what's the numerator become? Okay? Same thing in the denominator. Let's put in another fraction template there. What's our common denominator going to be in the denominator? Y. So this stays 5 over y. And what does 4 become? 4y over y. Good.
I can't get mine like that.
Okay, so then you're going to have 1 plus 3x. I'm going to do this in balance. 1 plus 3x over x over 5 plus 4y over y. Right? This is the same exact thing we saw in our homework. What do we do? Keep, change, flip. Keep, change, flip. So then all we would have left is to multiply this out. Y times 1 plus 3x over x times 5 plus 4y. Distribute out and finish. Okay, so our last step to solve this would be to distribute out here. I'm going to come over here to finish it because I'm running out of room. And we get y plus 3yx over 5x plus 4xy. Okay, we'll finish the rest of the lesson the next day. Your homework for tonight is lesson 3 homework. Your weekly project is due next class.